Let's start with some math in the wild where we take a look at some math that you may be seeing in the news. This week, we're going to talk about some graphs, and specifically, we're going to talk about the scales of those graphs. And we're going to talk about how when you pick a scale of a graph, you do so in order to tell a certain story. And that's what we're going to talk about using these graphs. These are graphs of where new cases are increasing. So these are the states where the cases of COVID-19 are increasing. The new cases are increasing every day. To explain a little bit about what that means is every day a large number of people are being tested for COVID-19. The number of tests that come back positive on that day are called the new cases because those are the new group of people that we now know have contracted this virus. We want that number to go down every day. So if there were 100 new cases today, we want tomorrow that number of 100 to go down. Once that number starts going down for a number of days in a row, that means that what we're doing, the social distancing, the not going to school, all that stuff is working because the new cases are going down, fewer and fewer people are getting the virus. Now, the reason I chose this article and these graphs to talk about is because one sentence in the introduction. It says, where new cases are increasing. These states have had recent growth in newly reported cases, so their numbers are going up. And here's the important sentence. Scales are adjusted for each state to make the curve more readable. Let's talk about what that means. In order to do so, I'm going to zoom in on two specific states. Illinois, which you'll notice at the time of this printing, had just about 58,000 total cases. That number is now up to near 80,000, the last I checked. So we're going to look at that case, which has a high number of cases in Illinois, and we're also going to compare it to Wyoming, which at the time of this printing had a total of 566 total cases. So a big difference in Illinois and Wyoming. And we're going to use those two as an example to talk about why these scales may have been adjusted. So let's zoom out and take a closer look at those two states. I want to draw your attention very quickly. The first thing I want you to notice about these two graphs here are the vertical scales. On the vertical axis, we have the number of new cases in each state. But there is a very big difference between the scale for Wyoming and the scale for Illinois. And the reason is the magnitude of the cases in those states, meaning the number of cases that there are. In Illinois, the number of new cases each day at its peak right here was right around 3,000 cases. So that means in one day there was about 3,000 new cases, a little bit more, you can see. Whereas the peak in Wyoming came on this one day up here, that's just around 70. I imagine that's around 70 cases if I'm using the scale for Wyoming. That is a really big difference. So you can understand why they may have chosen to use different scales here. Now, we talked in an earlier video about linear scales and logarithmic scales. These are both linear scales. The way I can tell that is because the jumps are always equal. On our left scale, it goes up by 1,000 each time. Up by 1,000, up by 1,000, up by 1,000. So we are always increasing by 1,000 on Illinois. Whereas in our Wyoming graph, we are making jumps of 20. It's a much smaller jump, but it's always consistent, which means both of these are linear scales. But they are very different scales. And I want you to think to yourself, why? Why might I want to use different scales? Why might it be not so great to take the information about Wyoming and place it on the graph with the scale of Illinois? To answer that question, I want to first look at the graph about Wyoming. If I follow this graph and follow my pointer, I'm following this line which represents the 7-day average. And you can see when it goes up, when it goes down, when it spikes, every little movement in the graph you are able to see clearly because the scale is appropriate. But these numbers are all really small. They're all around, most of them are under 20. If I plotted that information on my graph from Illinois, can you imagine what that might look like? Again, think about our scale. We are jumping up by 1,000. So the number 20 on our Illinois graph would be somewhere right around here, if you can see where I'm drawing. right around here. So if I were to plot data, follow my point, all around 20, it would be all right around here, very, very far. And this is even too high. This is probably more like 100. 20 would be almost touching the bottom. So the whole line would never go up or down unless you zoomed in really, really far. But if you were just looking, you would get no information from that graph. So if you use the wrong scale, your graph might not tell the story that you're trying to. Let's take a look at puzzle of the day number 12. It was another balance puzzle. So the first thing I do when I look at these puzzles, or any math problem really, is I try to organize all of the information that I have. The most important piece of information seems to be that there is a total weight of 48 pounds, or 48 ounces, or 48 Huzama-Watsits. They don't really give me a unit, so it doesn't really matter. Another piece of information that I have here is that we seem to have perfectly balanced hangers. Each hanger is perfectly balanced, and I can tell that because it's a straight line. And that's really helpful for me because a perfectly balanced hanger means that it is evenly distributed, the weight on the left side and the right. So that seems to be all the information we have here. We also have a number of shapes hanging. The second thing I like to do after I organize the information is I like to visualize my goals. It's pretty clear in my problem here. My goal is to tell what each shape is equal to. That seems to be the only goal here, which is wonderful. My next step after I visualize my goals is to persevere through adversity, which in math problems usually means making a few mistakes and trying to figure out as you go. So let's see how we do here. I have 48 as the total weight. The first thing I'm going to do is notice that this is broken in half on each side, so I know that this side equals 24 and this side equals 24. I think I'm going to start on the left side here. Worry about the right side later because that looks a little bit more confusing. I don't really know what all of this is, but we'll address that later. So on my left side, that 24 is also split in half, which tells me I have 12 over here and 12 over here on the right and the left. If I look to the furthest point on the left, I'm very happy because I know that each of these shapes equals 6 because there are 2 of them there and they total 12. So already I've found 1/3. I've reached 1/3 of my goals. That's a good start. What I'm going to do with that is I'm going to label all the other blue blocks that I have there and hope that that gives me some information. So now I've figured out this side, so I'm good with that 12. I have a bunch more hangers to go here. So I'm just going to look from left to right. Let's see. Over here I have a weight of... Whoa, didn't mean to do that. Over here I have a weight of 12. One of them is 6, and then there's 2 different shapes, so I can't figure that out yet. But if I look at this hanger, I know that these 3 stars are equal to 6 because it's balanced, and the only weight over here is 6. So that's really cool. That tells me that each of these stars is a weight of 2 because 2, 4, 6. So already I know 2 of my shapes. So I'm going to label all of my other stars here. And now I think that I can figure this out because if I look over here, I know that this portion of the hanger has to equal 12 because it was half of this 24 up here. And I know that the blue and the green together make 8, which leaves me with this little hexagon here, this yellow hexagon. I think it has to be 4. And checking my work there, 6 plus 4 plus 2 does equal 12. And I want to check the right side of the hanger too. So I'm going to label that other hexagon as 4 just to make sure these 3 values are correct. This 24 was split into 12 and 12. Let's make sure that this 12 works. 6 plus 4 is 10 plus 2 is 12. So let's give that a little check. Okay, now let's check this one over here. I don't know that we checked this one. 6 plus 4 plus 2. Yep, we already checked that one. That one was good. 12 plus 12 is great. And then we know these 2 equal 12. That means this 24 is correct. So our left hanger is all correct. We've already checked one of the right 12s. let's see this one. This 12 is split into two, which means this side has to be 6 and this side has to be 6. Well, the right side is definitely 6 because it's hanging there. It says 6. And on the left side, if each of those stars is 2, that does in fact equal 6. So this 12 is checked off, and 12 plus 12 equals 24, and 24 plus 24 equals 28. We have found a solution that works for every single hanger. I hope you followed along. I tried to do it step by step. There are so many different ways that you could do this hanger, though, so don't think this is the only way you have to follow. Just notice some of the strategies I did and try it again. See if you can come to your own way of finding these 3 weights. But you should get the same 3 weights that I got because they seem to work out. Puzzle of the day number 13 is going to be brought to you by Miss Kirkinides. She is our guest puzzler of the day. Remember, if you would like to submit a puzzle, all you have to do is send me an email, send me a message, give me the puzzle. I'll talk you through how to create a video talking about the puzzle. If you don't want to talk about the puzzle, I can introduce the puzzle for you. But either way, submit those puzzles because it's great when we have puzzles from different people. So I'm going to let Miss Kirkinides take this one away.
Hi everyone, it's Miss Kirkinides, and I wanted to go over puzzle number 13 with you all. I actually ended up getting this t-shirt when I went on a trip last April to Cooperstown. I thought it was really cool because there was a math problem on it, but at first I didn't get it. It said 6 plus 4 plus 3 equals 2. Let's think about that for a while. So somehow when you add 6 with 4 and 3, you have to get an answer of 2. Check out the next episode for the solution.
Give you all a small hint for this puzzle. You might want to look up what Cooperstown is. Thank you all for joining me today. I hope you learned something and enjoyed the episode. Good luck on that puzzle. It took me a while. It was a really tricky one. As always, we're going to end with some positivity. And again, I say this every time, you got to make time to practice being positive, especially in times like these, which can be scary and we're stuck at home. And a lot of us are getting tired of this. Try to make some time to be positive. And it's difficult. It's not easy. It doesn't come to people easy. So keep trying every day. Try to have a moment where you just look for something positive. So for today, I want to talk about something that I heard the other day when I was having a conversation. And this person I was talking to heard me say something. I said something like, oh yeah, but I can never do things like that, so it doesn't, that wouldn't work for me. They suggested something for me to do something. I said, oh, that would never work for me. And the person I was talking to is a good friend of mine. They know me well, and they said, you always do that. You make rules for yourself. And that's definitely something that a lot of people do without even really noticing it. You can just make up these little rules and say, oh, I can't do that, or I that stuff doesn't work for me, and you write off even trying something. So what I want to leave you guys with this week is try to notice if you're making rules for yourself, if you're saying that things don't work for you, or if you can't do something a certain way, or I only do things this way. Sometimes those rules are not real, and we just make them up. For example, if you're having a rule that thinks, oh, I can't have a good day today, I'm stuck at home, I'm going to have a bad day. Don't make that rule for yourself when you wake up in the morning. That doesn't have to be the rule. So if you notice yourself making rules for yourself, try to challenge them. Try to break those rules where you can, because everybody likes to break rules. All right, I will see you soon. I promise it won't be this long for episode 14. See you soon. Bye-bye.